Hello, dear students. Let's start one question from photogrammetric surveying. A tower is photographed from an elevation of 1000 meter above datum. The radial distance measured from principal points to the bottom and top of the tower are 80 meter and 100 meter respectively. The bottom of the tower is at 300 meter above ground level. Calculate the height of the tower. So let's draw the figure to understand the question. See, it is given that tower is photographed from an elevation of 1000 meter. 1000 meter means it's 1 kilometer. Okay, so obviously the flying height they have given. So flying height is denoted by capital H. So they have given. So this is your flying height, and the radial distance measured from principal point to the bottom and top of the tower are 80 meter and 100 meter. So suppose this is your ground level and this is your tower. Suppose this is your tower. Flying height is this is your flying height. So this flying height, this is your capital H. Okay, so this capital H, that is 1000 meter. Okay, and this we have to determine the height of the tower. Now in such cases, first we are supposed to find out the relief displacement. Now what do you mean by relief displacement? Relief displacement, see what happens, this concept is applicable when the ground is not uniform. Okay, it is somewhere it is rising, somewhere it is falling. So the ground, as it is not horizontal, the scale will change from point to point. Okay, so in as we are taking a photograph from a certain height, the points here they have mentioned that the radial distance measured from principal point to the bottom and top of the tower are 80 meter and 100 meter. Okay, so 80 meter and 100 meter corresponding to the top as well as bottom respectively. Okay, now relief displacement formula is small d is equal to r h upon capital H minus h1. See, now I am writing h and h1. Basically small h will be your height of tower which we are supposed to find. Okay, we don't know small h, but at the same time small h1 they have given. Small h1 is your bottom of the tower. Okay, so that they have given 300 meter. Now let me write the definition also so that you can understand. So when the ground, this you remember, because until your concepts are not clear, then you will not be able to solve. So when the ground is not horizontal, the scale of the photograph varies from point to point. Okay, so the ground relief means the topography. The ground relief is shown in perspective on the photograph. So basically it is a perspective projection. So what happens basically, that every point on the photograph will be displaced from its original position. Okay, so there will be some displacement. There will be some, due to this there will be some displacement of each point, and actually this displacement is known as relief displacement. Okay, so here you have to remember this formula. Now another thing you should remember is this relief displacement, which is denoted by d. Actually it is inversely proportional to your flying height. Okay, remember this. This is one of the most important relationship between height of flying and relief displacement. Okay, and another thing you can remember is relief displacement increases as the distance from principal point also increases. So that is directly proportional. Relief displacement is directly proportional to distance from the principal point. So these two things you remember, right? So here, see, we have seen the formula. Relief displacement d is equal to small r into h upon capital H minus h1. So h1 is 300 meter, which is the bottom height from above ground level. So they have taken given both the heights. Okay, now there is another formula also for relief displacement. Another formula for relief displacement is d is equal to r minus rho. So here basically we are taking the difference of the two heights. Okay, one is 80 meter and another is 100 meter, right? So 100 minus 80, so it is 20 meter. Okay, so relief displacement we have found out, it is 20 meter. So let's put in the value of relief displacement in our original formula. So our original formula was d is equal to rh upon h minus h1. So 20 is equal to, our r is 100 into h we are supposed to find out. Capital H is your 1000 meter minus h1, that is 300. So small h, that is height of tower, small h will be 20 multiplied by 1000 minus 300, that is 700, divided by 100. So this will cancel. So 7 2s are 14. So it is 140 meter. Okay, this is our answer. Okay, thank you very much.